So in the previous video we studied the basics of electropneumatic circuits. I know it is quite a bit difficult to completely get to terms with what electropneumatic circuits are directly, but in this lecture I will try to explain to you a bit in a simple manner how to draw the electrical part of the electropneumatic circuit and what exactly it is. Okay, so to start with, first let us see what a basic electrical circuit looks like. Right, see, in a basic electrical circuit what do you have? You have a battery. You generally have a switch. That switch is used to what? That switch is used to turn on and turn off the flow of current, right? So that is the function of switch, to control whether the current is flowing or not. Then there is a load. The load can be anything. The load can be a DC motor, the load can be a fan, the load can be a bulb. Right now I have just drawn a bulb. This is just for explaining purposes, right? So this is the simplest circuit possible in any electrical system, right? This is the battery which is providing the voltage. This is the switch which we turn on and off, and this is the load which turns on and off based on the position of the switch. So what exactly are we trying to control? We are trying to control the bulb, and to control the bulb we are using this switch. Okay, so rather than drawing this diagram like this, in electro circuits of the electropneumatic circuits, which is also known as the relay circuits, see, in that what do we do? You have to remember, see, what is the step one? Cut the circuit in the center of the battery. Cut the circuit in the center of the battery. So this is my battery over here, right? What am I going to do? I'm going to cut the circuit in the center of the battery, right? So when I cut the circuit in the center of the battery, what happens? There is positive on one side, negative on one side. Then what I will do, I will make this circuit in a straight line, right? So I will open these folds, these 90-degree folds, and make it into a straight line, right? All these 90-degree folds. So what will this circuit look like? See, there will be a positive voltage over here, straight line. See, this straight line, first comes the switch. So I will draw the switch. After the switch comes the bulb. So I will draw the bulb over here. Bulb is any load, it doesn't necessarily have to be a bulb. Then will come a straight line, and then we come to the negative part of the battery, right? So this is the same circuit represented in another form. In this form, what are we doing? We are keeping the plus 24 volt over here, or rather the positive voltage, whatever might be the value of positive voltage over here, and we are keeping the negative voltage over here. So this is your negative and this is your positive. This is your switch and this is your load. So this becomes your circuit. Then what is the next step? The next step is to rotate this circuit clockwise by 90 degree. The next step is to rotate this circuit clockwise by 90 degree. So how will that circuit look? This will be the positive voltage. This will be the switch. Okay, I am drawing it on this side. It doesn't matter how you draw the switch, but somehow you have to draw the switch. And here comes the load. Okay, and this will be a ground. So this will be a positive voltage and this will be a negative voltage. So this is how you convert a normal circuit into your relay circuit form. This is your normal form, which we have been drawing since we were in school, and this is the relay form, right? Now I will just explain to you another example of circuit in parallel, right? So how will you exactly draw a circuit in parallel? Let's see. Over here, imagine that there is a circuit like this. There is a battery over here. There is one switch to control this bulb, right? This is the complete circuit. And there is another switch to control another bulb, right? There is a second bulb over here. So this is your switch 1, this is your bulb 1, this is your switch 2, and this is your bulb 2, right? So you have to make a circuit for this, a relay circuit for this. The rules are always the same. Cut it in the center. After you cut it in a straight line. So how is this circuit going to look? See, you have to understand how this circuit is going to look. So there will be positive voltage over here, there will be negative voltage over here. Now from positive side we are walking. What is the first thing that comes here? It is a split, right? It is splitting into two parts. So that is the same thing that we will do. We will walk like this and we will create a split. So one is going straight and one is going after a split. So in the straight one, right? In the straight one, what is the first thing that we are finding? A switch. So this is the first switch that we found. Then what are we finding? Then we are finding the bulb one. Okay, right now I will just show the bulb with a rectangle. Okay, this is your bulb one. In the other arm, what is happening? Again straight, there is a switch. So there is this switch 2. This will be your what? Switch 1. This will be what? Switch 2. Again going straight, what are you encountering? You are encountering bulb 2. So over here you have bulb 2. Then what is happening? See, both the arms are again coming together over here. Both the arms are coming together. So that is what you draw. Both the arms come together over here. After that, what is there? Directly you have the negative end of the battery. So I'll draw it over here rather than over here. So it will be negative end of your battery. Again, what do you have to do? You have to rotate it by 90 degree. So how will the circuit look? This will be a positive end. From here you have to draw this. This will be a switch 1. Over here will be a bulb 1, right? And this will be ground. Now rather than drawing it, okay, I can draw it like this. See, this will be my switch 2, this will be my bulb 2, and this will be ground. Okay, I can either join it over here, right? Or another thing what I can do, I can directly take it down and I can say let us make this line a bit bigger. Let this big line be ground. It doesn't matter na, how big the line is. So let this be ground. Similarly, rather than drawing this over here, what am I going to do? I will just use this, and rather than drawing it like this, what I will do, I will extend this line further. I will just draw it straight and let this entire line be positive voltage, right? And this entire line be ground. Ground is same as negative voltage. So this is your switch 1, this is your switch 2, this is your bulb 1, and this is your bulb 2. Okay, so this is how you can draw your relay circuits, right? So hopefully this part is clear to you, and with this now we will see what exactly relays are, how they work, and we will see some working of this also. Right, so in this section we will be seeing the basic workings of a relay, how exactly it works, right? Before seeing that, let us just see how we can draw those circuits and the circuits which we just saw, right? These are the circuits that we just saw over here, right? This one, and over here this one. So let us see its animation in Festo Fluid Sim, right? So what do we need? Initially, see, initially we need a positive voltage and a negative voltage, right? Those are the two things that we need. So over here, see, we have this positive voltage and we have ground, right? So this is positive voltage and this is the ground. Then what do we have? We have a switch and we have a load. That load can be anything. In this case we have taken a bulb, but in this case we will take a DC motor, because DC motor is the load which is available over here. So this is your load. And similarly, right now I will use a push button. I will explain you the difference between a push button and a switch, but right now I am connecting a push button. So see, I have made this same connection which you are seeing over here, right? This same connection, you can see it side by side. See, sorry, this same connection that we are seeing over here has been drawn over here, right? So with this I will just run the simulation. See, as soon as I run the simulation, there is nothing happening right now. okay, because the current cannot pass because the circuit is open. But as soon as I push this push button, the circuit closes, and see, the motor has started rotating, right? But see, I am currently holding down the mouse, okay? As soon as I leave the mouse, the circuit opens. As soon as I leave the mouse, the circuit opens, right? So what is the default position? By default, see, I am not pressing the button right now. I am not pressing the push button right now. So when I am not pressing the push button, the current is not flowing. The circuit is open. So when I am not pressing the push button, the circuit is open. But when I push the push button, the circuit closes. So this is one type of push button that is possible. Okay, now this is the thing that we see commonly. Now there is another kind of push button that can be used in your circuit. Okay, so I have just created another same circuit. Over here, rather than using this push button, I am going to use this push button, right? Now you can immediately see the difference between the two push buttons. See, over here the circuit is open, right? And over here the circuit is actually initially closed. Now see, if I run this, see, I am not pushing any push button right now. What is happening? This push button is keeping the circuit open. On the other hand, this push button is keeping the circuit closed. So this push button, the one on the left side, is known as a normally open push button. What does it mean? When we are not pushing the push button, it is in open state. And this push button on the right side is what? It is a normally closed push button. What does it mean? When I am not pushing the push button, it keeps the circuit closed. Now see what happens when I press the normally open push button. The circuit closes and the push button becomes functionally closed. So right now it is normally open. As soon as I push it, it becomes functionally closed and the circuit is complete. And the opposite things happens for the NC switch, normally closed switch. So normally open is known as NO and normally closed is known as NC. So as soon as I push this NC switch, what happened? The circuit opened, and because of that the motor stopped, right? So NC when pushed turns into FO. NC is normally closed, and when normally closed is pushed, it turns into functionally open. And this is what? This is normally open, and when I push normally open, it turns into functionally closed, right? So this is how NO turns into FC and NC turns into FO. NO stands for normally open. Normally open when operated turns to functionally closed, and normally closed when operated turns to functionally open, right? So this is a very important point about what is normally open, what is functionally closed, what is normally closed, what is functionally open, right? So hopefully you have understood this point clearly. So after this, I will just like to explain to you how a relay works, right? See, just a minute. Over here, see what is happening. There are two separate push buttons that I want to operate to control two different motors. See, for some reason I have a system in which at any given time at least one motor should be on, right? At any given time at least one motor should be on. So, and only one motor should be on at each time. So what do I mean to say? That when I turn on this motor, let us call this motor, the one on the left, let us call this motor 1, and this on the right, let us call it motor 2. So I want to make a circuit in which as soon as motor 1 starts, motor 2 should turn off, and as soon as motor 2 starts, motor 1 should turn off, right? So this is the circuit that I want to design, that when motor 1 starts, motor 2 should turn off, and when motor 2 starts, motor 1 should turn off, right? Now basically what am I doing? I have to control two circuits simultaneously. So I have to control two circuits simultaneously. When I have to control multiple things simultaneously, or when I have to control a different voltage thing using a low voltage, or a means I have to control a different voltage item using a different voltage controller, at those times I use a switch, I use a relay, right? So how does a relay exactly work? See, this is a relay. Okay, so I will just explain it to you. I have explained it to you once before. I will just explain it to you once again. Basically, what is a relay? Sorry. Okay, see over here. What is a relay? A relay is just a box. In this box, there is a solenoid coil, right? So there is wire over here. This wire comes out from two ends. This coil can be controlled by sending a voltage into it, right? So you can control whether or not there will be current in this through this switch. When you turn on this switch, the coil will get electric current, the solenoid will get charged, and it will create a temporary magnet. Over here you have another connection which is known as a common connection, right? Over here you have a connection which is known as a common connection. Over here you have a metal plate which is like this, right? This is a metal plate which is connected to common. Over here there are two connections, one over here, and I will just rub this a bit because I need the space above, right? And sorry, just a minute, just rub out this part. I need a bit more space over here, right? So there is a connection over here and there is a connection over here. This upper part, when there is no current flowing through the coil, see, common is connected to this, so electric current can flow from common through this, right? That is how the current can flow. So this point is known as NC, because this is what, this is currently connected to each other, so it is normally closed. On the other hand, this lower connection is known as NO, because see, there is a gap between these two, so it is not directly connected to this, so electricity cannot flow through this. But as soon as I turn this switch on, see, I will draw this same diagram over here. The difference will be that I will turn the switch on. As soon as I turn the switch on, what is going to happen? The solenoid is going to get electrically charged, right? The electricity is going to flow through the solenoid. As soon as electricity is flowing through the solenoid, there will be a magnetic force. Because of this magnetic force, what will happen? This common strip will get attracted downwards, right? See, I am drawing it a bit exaggerated, but basically what will happen? The common strip will get attracted downwards, right? So what will happen? The upper connection will be broken and the lower connection will be made. So the lower connection, because we are passing, see over here we are not pushing the push button, so it is NC and NO. Now we are pushing the push button. Because of the pushing of the push button, this NC turns into functionally open and this NO turns into functionally closed. Okay, so always remember, in a relay there are three main connections. What are the three main connections? The first connection is the coil connection, the second is the NC connection, and the third is the NO connection. When there is no current through the coil, NC is NC, NO is NO. When there is current through the coil, NC becomes FO and NO becomes FC. Okay, so this is what you have to remember. So based on all this, let us see how to draw it. So just now I told you there are three main connections. There is a connection of coil, there is a connection of NC, there is a connection of NO. So there are three symbols, right? Coil, NC, NO. This symbol is for the symbol of coil. Similarly, this symbol is the symbol of NO because it is normally open. And this symbol is the symbol of NC, normally closed. So this is the symbol of relay coil. This is the symbol of relay normally open, and this is the symbol of relay normally closed. Now this is a general symbol of normally open and normally closed. This will also be used for other things such as proximity switches and all, but it is also the symbol for relays normally open, and this is the symbol for relays normally closed. Now see, initially what was my requirement? My requirement was that I have to create a circuit in which when I push one push button, one motor should turn on and the other should turn off. And when I let go of the push button, the second motor should turn on and the first motor should turn off. So to draw a relay circuit, what is the first requirement? Always there should be a high voltage and there should be a low voltage, right? So I have to control everything with a push button. So first I will need a push button, right? With that, I am going to use a relay. I am going to use a relay. So what are the three things of relay? There is a relay coil, there is a relay NO, and there is a relay NC, right? It is not necessary that each and every coil's NO and NC has to be used. You can use either NO or NC, or you can use both. But definitely you need a coil. Now, if you don't have the relays coil, then how are you going to control when it turns on and when it turns off, right? So whenever you're creating a relay, you will definitely always need the relay coil symbol. Whether you need the NO symbol or not depends completely on the application. In our case, we will be requiring both NO and NC. Okay, so right now what am I doing? See, I'm connecting over here. So what does this mean? See, I will just turn it on right now. So when I push this push button, the relay 0 will get electricity. And when I don't push this push button, the relay 0 will not get electricity, right? So what I have to name this relay something, right? I always have to name it. So what will I name it? I will name it R0, right? At present I will name it R0. Now I will use the functionally NO, normally open switch of the relay, right? So sorry. So over here I will use the normally open switch of the relay, and again I will name it R0, right? Similarly, I will use a normally closed connection of the relay and I will call it R0, right? So now what? Now I will connect this over here. So everything is getting 24 volts. Now what do I have to do? I have to control two motors. Means it can be any output. Over here we have only a DC motor and solenoid. So right now I will be using motors to explain it to you. So here I have my two motors. I will connect them like this. And now see, when I start my circuit, what is happening? See, one motor which is connected to the NC is running, right? Because I haven't pushed the push button. But as soon as I push the push button, see what will happen. This which is NO will get converted into FC, and this which is NC will get converted into FO, right? So the first motor started and the second motor turned off. As soon as I leave this push button, the first motor will stop and the second motor will start, right? So this is how this is working, right? See, as soon as I push this, relay 0 gets current. Because relay 0 gets current, the positions are switched. See, initially what is happening? Initially it is in this condition. When we haven't pushed the push button, it is in this condition. But as soon as we push the push button, it gets converted into this condition, right? So this is exactly what is happening over here. I push the push button, NO gets converted into FC and NC gets converted into FO. I leave the push button, it is again back to NO and NC, right? Just one more thing to show you. Now this is what? This is a push button. So whenever I have to keep the circuit on, what do I have to do? I have to keep the push button pushed. As soon as I leave the push button, it stops. So rather than doing this, what can I do? I can use a switch over here. So this is the symbol for a switch. It is similar to push button, but it has a V over here. See, it has a V over here. Connect this to this. We'll connect this to this. Start it. Now see, I'm pressing it and leaving it. I have left it completely. Now this motor is on. Motor 1 is on. Motor 2 is off. Why? Because relay 0 is getting current. Again I press the switch, relay 0 stopped getting current, motor 2 is on, motor 1 is off. Right? So this is how the relays are used, and this is exactly what we will be doing in our circuit. The difference is, rather than controlling motors, we will be controlling solenoid valves. Right? So rather than putting motors over here, what are we going to do? We are just going to put solenoid valves over here. Right? See, this is the symbol for a valve solenoid. So the same thing will happen. Right? See, turn on. Initially this valve solenoid is powered off. When I press this valve solenoid is powered on. Right? So where can I use a circuit like this? See, a circuit like this can be used to create and control a double acting cylinder. Right? How can you do it? See, I will just drag this circuit over here. I can, just now I told you, I can use this circuit to control a double acting cylinder. Now, if you have understood this properly, and if you have understood the working of double acting cylinders properly, you can draw this by yourself also. Okay, but I will just try to explain this to you. Right? What am I going to do? I'll put it right now. I don't need the sensors. I will be controlling it completely with a switch. Right? So imagine that there is some application where when I press the switch, the solenoid, the piston should move forward, and when I leave the switch, the piston should move backwards. Right? So there is some kind of a stamping operation kind of a process which is manually controlled. So when I want the stamp to come down, I press the push button. So the stamp comes down, and when I want the stamp to go up, I leave the push button. As soon as I leave the push button, the piston moves upwards. Right? So I will again repeat what I want. When I push the push button, the stamping machine's piston should come downwards so that it gets stamped, and as soon as I leave the push button, the piston should again move upwards. Right? So this is the circuit that I want to create. So as this is an electropneumatic circuit, I will have to use solenoid valves over here. Right? These are my solenoids. This is a solenoid operated solenoid return valve. So let us name this solenoid with our normal pattern. This is what Ka plus, because for solenoids we use the symbol K, and it is causing A plus motion, forward motion. So it is Ka plus, this is Ka minus. Right? Over here we have put two valve solenoids. Right? Let us name this valve solenoid as Ka plus, and I will just move it a bit. Let us name this valve solenoid as Ka minus. Right? See, now what happens? As soon as I turn it on, see, Ka minus is getting electricity. Because Ka minus is getting electricity, this position is active. Now when I push this push button, what is going to happen? It is going to get closed. Because of that, relay 0 will get electricity. Because relay 0 gets electricity, this connection, this NO connection of relay 0 will become FC, and this NC connection of relay 0 will become FO. So Ka plus will start getting electricity, and Ka minus will not get electricity. Because Ka plus is getting electricity, this position of the solenoid valve will get active, and the piston will come outwards. Right? See, the piston came outwards. So it has stamped. As soon as I leave the push button, the piston moves inside. Stamp, inside. Stamp, inside. Isn't it very easy? So this is exactly how the system will work. Right? I press the push button, it comes forward. I leave the push button, it comes backward. Right? So rather than keeping a push button, what can I do over here? I can put a switch that when I push the switch, the piston should come out and stay out. When I want the piston to go back, I will again press the switch so that the piston goes backwards. So on, I press the switch, the piston has come out, and now when I press the switch again, the piston goes back. So in this way, I can control when the piston comes forward, when the piston goes backwards. Right? So this is a simple circuit to control the operation of a piston. Now over here you must have noticed that we have to control both the motions of the piston, the forward and backward motion. We have to give some kind of an input. For example, when we had the push button over here, what did we have to do? To bring the piston forward, we had to press the push button, right? Pushing the push button move the piston forward, and not pushing the push button move the piston backwards, right? Pushing it forward, not pushing it backwards. When we put a switch over here, instead of a push button, we put a switch over here and connected this. What happened? When we press the switch, piston comes forward. When we press the switch, piston goes backward. So it is the pressing of the switch which is operating both the motions: forward motion, backward motion, forward motion, backward motion. Now imagine I want to create a circuit in which as soon as I press the switch, the the piston should move forward and backward, and forward and backward, forward and backward automatically. How can I achieve this? Well, it is very simple. See, how can I achieve this? When I start, what is happening? See, when I push this switch forward, piston is going forward. When I leave it, piston is going backward. Now, what is the kind of circuit I want? In my circuit, as soon as I press this switch, the piston should move forward. After the piston has reached its complete forward position, the piston should return backward. Again it should go forward, again it should go backward. So basically the piston has to make reciprocating motion continuously as long as the switch is closed, right? So this is the circuit that I want to prepare. So see, if you can imagine, how will I know when the piston has reached its complete end positions, right? So to know whether or not the piston is in initial position, that is in completely retracted position, see, now the piston is in completely retracted position. So I know that because the piston is in retracted position, it must move forward. Once it moves forward, I should know that the piston has reached its extreme end position, and now the piston should move backward, right? So I should know what is the current position of the piston. Only by knowing the current position of the piston can I control its motion. So how can I know the current position of the piston? To know the current position of the piston, we will have to use proximity sensors, right? We are using proximity sensors. So we will have two proximity sensors. One will be A0. It will be at the initial start of the piston, right? And there will be A1. It will be at the end of the piston. So A0 signifies that the piston is in retracted position, and A1 signifies that the piston is in completely advanced position, right? So see, when I push start, currently nothing is happening. It goes forward. As soon as it goes completely forward, what should happen? The piston should move back. For the piston to move back, what should happen? Ka minus should get active, right? So Ka minus should get active when A1 is active. Okay, see, this is a very important statement that I am saying right now. Please understand, when should Ka minus get active? Ka minus should get active when the piston has reached A1. So what we will do, we will put another NO switch over here, and this NO switch will be of Ka minus, A1. This will be of A1. Why? See, now I will just slow it down so that you are able to see it clearly. Okay, see now. As soon as I turn this on, see, as soon as I turn this on, electricity reached arrow, so it reached Ka plus got active, piston is moving forward, right? Piston is moving forward. Now the piston will reach A1. As soon as it reached A1, what will happen? This A1 will get closed. But what is happening? Because of this R0, because R0 is open, nothing can happen over here. So what I have to do, I have to remove this R0 from here right now. I will connect it over here, right? Now let us see the circuit. As soon as I turn this on, Ka plus gets electricity, piston will start moving forward. Piston will keep moving forward till it reaches A1. As soon as it reaches A1, see this circuit got closed. Ka minus got electricity. But what is happening? Ka minus has also got electricity and Ka plus has also got electricity. So what will happen even if I do anything? It is not going to change position, right? So what do I have to do? I have to ensure that once the piston has started moving forwards, Ka plus stops getting electricity, right? See, currently what is happening, as soon as I turn it on, even though the piston has moved forward, even though the position has changed and the piston has started moving forward, Ka plus is in active position and Ka plus is still getting electricity. But when should Ka plus get electricity? Ka plus should only get electricity when it wants to switch the position of the valve. And when should Ka plus get electricity? When the piston needs to move forward. And how will we know that the piston needs to move forward? When the piston has completely retracted. And how will we know that the piston has completely retracted? When A0 sensor is sensed, right? So what is the logic? Piston will completely retract. As soon as piston completely retracts, A0 sensor will be sensed. As soon as A0 sensor is sensed, Ka plus should get active. As soon as Ka plus gets active, piston should move forward. So over here, what am I going to do? I'm going to delete this, and over here I'm going to put an A0 switch. Okay, A0 NO switch. Right now it is showing NC because the piston is at initial position. That is the only reason. It is the same as this. Okay, it looks same as A1. Initially, because it is closed, it is looking like this. We will see this in a moment, right? So see what is going to happen. I will just push it and pause it. See, I have, okay, I will just put it back, right? As soon as I push it, okay, as soon as I push this switch, what will happen? Here electricity, see, just a minute, see, initially A0, A1 both are open, right? As soon as I push this connection is closed, so R0 will get electricity. Because R0 got electricity, what will happen? See, this R0 will get closed. Okay, we will see that in a minute. And see, A0 is also closed. Why is A0 functionally closed? Because the piston is currently at A0 position, right? That is why A0 is functionally closed. R0 is also closed, A0 is also closed, so Ka plus is getting electricity. Because Ka plus is getting electricity, this position of the valve will get active, right? This position of the valve got active, so compressed air is going to the left side. So what will happen? Compressed air will go to the left side. Piston has started moving forward. As soon as piston moved even a little bit forward, what happened? A0 sensor was desensitized. Because A0 sensor was desensed, this got open. Because this got open, Ka plus got deactivated, right? Now the piston will move forward till it reaches A1. As soon as it reaches A1, the circuit is closed. Ka minus got electricity. Now Ka minus will do what? It will activate this right position of the valve. It activated right position of the valve. Now what will happen? The piston will start moving inwards. As soon as the piston moves even a little bit inward, A1 will get desensed. Because A1 will get desensed, Ka minus will become deactivated. Okay. See, Ka minus became deactivated. Now the piston will move backward till it reaches A0. Again when it reaches A0, see what happens over here. The circuit got closed. Again Ka plus is getting electricity. Position will change. Piston will move forward a little bit. A0 will open, but the piston will continue moving forward. Right? So this is how the circuit will be maintained. So this is a simple electropneumatic circuit to achieve A plus A minus motion. Right? So this is how the system will work. Right? Now, before ending this session, I will just like to explain to you what latching circuit is. right? Hopefully you must have understood how to draw A plus A minus circuit. See, it is pretty simple. It is not that difficult to understand, right? Right now, just for time being, I will put it as this so that you see the circuit properly as it should be seen. Now, I just want to explain to you what is the problem of using a push button and what is the problem of using a switch. See, if I don't use a switch over here and I use a push button over here, see what is the problem, that the system will operate only as long as the push button is pressed, right? Okay, sorry, I just made that one, right? So I just have to make it 0 once again for the system to operate. Again, the symbol changes because of that. That is the only thing. Now see, if I am using a push button over here, this system will operate only as long as the push button is pressed, right? As soon as the push button is left, the system will stop operating. That is the main problem. If the push button is pressed, I am pressing down the mouse button right now. That is when the system works. As soon as I leave the push button, it will retract to its original position and stop, right? So what is the problem in this circuit, that I have to keep the push button pressed continuously. I have to keep the push button pressed continuously for the system to operate. But what if I want my system to operate automatically, ki once it is pressed, it should keep on working till I press off. So what I will do, rather than using a push button, I will use a switch, right? So I can use a switch over here. Again, here what, I will start it and I can leave it. Now it will continue to operate continuously till I again turn off the switch, right? So I can turn off the switch and it will return to its original position, right? But there is a limitation of using switches in industry. See, this limitation can be seen by you in your building also. If you have a water pump in your building, right, a pumping motor in your building, then you will notice that it does not have a switch. It has two push buttons, one on push button and one off push button. What is the main reason for this? The main reason for this is that suppose you have turned on the motor, right? You have turned the motor on and the motor is pumping water to your upper tank, and suddenly the electricity goes, right? Electricity turns off because of some reason, the electricity supply turns off. Because of that, okay, just I will draw over here, right? So you have created this thing, you have this uh, pump in your building, right? So in your building you have, this is your building, this is your lower tank, there is a pump over here which is pumping water into the pump, and this is pumping water up to your upper tank, right? Initially you turned on the pump, so water was going to the upper tank. What happened, suddenly the electricity went off, right? The electricity went off. So imagine that you turned the pump on at 8 a.m. in the morning. What happened, at it was on at 8:05 the electricity went off. So electricity went off, you forget that you have turned on the pump, right? The pump is not pumping water. So because of your daily routine and daily time, daily things, what happens, generally the pump completely fills, it starts overflowing. As soon as it starts overflowing, you know that the pump, the upper tank is full, and you go outside and turn off the pump, right? This is how you do it in your house. Now what happens, at 8 a.m. you started the pump, water was being pumped up. At 8:05 electricity went, okay, electricity supply was stopped for some reason. What happens, because no water is coming out, you forget that you have kept the pump on, right? At 10 a.m. you go to your work, wherever you work, you go to your office, and you forget about everything. What happens, at 11 a.m. electricity returns. Because electricity returns, the pump will start. What will the pump do? The pump will take all the water from the lower tank, pump it into the upper tank. Possibly the upper tank will overflow. Okay, that is okay. Some amount of water was lost, but that is at least understandable. But at the same time, what will happen? Because the lower tank is now empty, there is no water in the lower tank. No water can be pulled up by the pump. If no water can be pulled up by the pump, what will happen? The pump will burn, right? And your pump will get destroyed, right? So just because when electricity went away, you forgot to turn off your pump, your system was completely destroyed. So when you come home back at 6 p.m., you notice that the pump has completely burnt out. So why did this happen? This no doubt happened because you forgot. It is 100% a human error. If you are very good and you perfectly remember that array my pump is on, I should turn it off. Just because there is no electricity does not mean that the pump should be kept on. 100% that is right, it is human error. But there should be some system to prevent this human error, right? So the system to prevent this human error is known as latching circuit. The system to prevent this kind of error from happening. What is the error in this? The error in this is that when electricity supply is stopped and restarted, electricity supply was stopped and then it was restarted. What happened? The system restarted, right? But you want to design a system in which if electricity supply is stopped and restarted, the system should not restart. The system should restart only when you push the on switch. So this circuit is known as latching circuit. The explanation that I gave you, this same logic is used in industries also. See, in industries, the chances of errors are large and the losses will also be large. Imagine suddenly there is this is a practical explanation. Imagine there is a large vat of oil or something, and because there are a lot of chips in it, right? Chips are being cooked, right? This is what actually happened in Frito-Lay's. If you have seen Mega Factories episode, the light suddenly went away. Because of that, the entire conveyor system stopped. So what generally happened, these wafers after cooking were taken out automatically. But because the electricity went away, these wafers remained in this oil. Now the oil is not going to cool down immediately, right? It is heated oil, no? It has high specific heat capacity. So these wafers were completely burnt. Because these wafers were completely burnt, the oil will become like black, and the oil will also become bitter because of the bitterness of the overcooking of these chips. Now if the electricity restarts, what will happen? The conveyor belt before this vat, it also has some wafers on it, means these are only potato chips, uncooked potato chips over here. But if the system, when the electricity comes back and the system restarts, what is going to happen? All these uncooked potatoes will fall into this same oil. If it falls into this same oil, these uncooked potatoes will also become bitter and black because of this reason, right? Because the oil itself is bad. So what do you want? Even after the electricity goes off and comes back on, the system should not restart. Why? Because before you restart the system, you have to change this oil, right? Only after changing this oil should the system be restarted, right? So that is why a latching circuit is compulsory in any system. Any system requires a latching circuit, right? So before we draw a latching circuit, you have to understand a latching circuit has three things. What are the three things, necessary things? A latching circuit requires a NO push button. This NO push button is your on push button, right? It is used to turn on the system. You need a NC push button. What is the function of this NC push button? This NC push button is used to turn off the system. And to keep the system on for as long as you want, we need to use a relay, right? We require a relay coil and we require a relay NO switch. Using this, we can create a latching circuit. Now, hopefully you have understood the importance of latching circuit, right? So I will create a latching circuit over here. So what we will do, rather than keeping this switch over here, we will be creating a latching circuit over here, right? I will just move this part a bit to the right so that I have enough space to draw a latching circuit. Now this latching circuit diagram is same, and this latching circuit diagram will be required for both your electropneumatics and electrohydraulics, and it will also be required for your PLC diagrams, right? So what are the three things required for a latching circuit? Three things required are a NO push button, a NC push button, and a relay coil and relay NO switch, right? So I have this NO push button. This is a normally open push button, right? Similarly, I have a NC push button. See, this is what? This is normally closed. When I push it, it will become off, right? This is NO. When I push it, it will become FC. This is NC. When I push it, it will become FO. And this is a relay coil which I have. Plus, I will need a relay NO switch. So these four things are required to create a latching circuit. So how is a latching circuit? First of all, there is the NO switch, start switch. Then there is a, see this NO switch. Then there is this NC switch. NC switch is connected to relay 0. And over here, we have a relay 0 in parallel to the NO switch. Okay, I will explain this to you in a minute. But this is how, this much part, these things from positive to negative, this is known as a latching circuit, right? So this is what, this is my start button, I will call it SRT. This is my stop button, I will call it STP, right? And this is also relay 0. Okay, now to explain this working, see, I will just turn this on. Okay, now see, as soon as I push the start button, okay, I have pushed, it is a push button. Okay, so it is just on for right now, it will become off immediately after it starts. See what is going to happen. See, electricity is flowing, electricity is flowing through the start push button, electricity is flowing through the stop push button. Why? Because it is in NC. This is FC, functionally closed. This is NC, normally closed. Electricity is going to R0. As soon as electricity reaches R0, what is going to happen? The R0 NO switch will get closed, right? So R0 NO switch will get closed. Just ignore the right part for right now. We will just focus on the latching circuit. As soon as R0 got closed, what happened? See, electricity is now going through the start button also. Electricity is going through the NO of the R0 also, and it is going to R0. After some time, what will happen? Because the start push button is a push button, I have left the push button. The push button will disengage. But even after the push button disengages, electricity is going from this R0 NO. Na? So from here, the electricity is reaching R0. So what is the relay 0 doing? The relay 0 is keeping itself on. The relay 0 is using a NO of itself to keep itself on. Right? So now this system will work automatically, completely automatically, till I push the stop button. It will keep on working, right? Now what will happen when I push the stop button? See, I will pause it again. I'll bring it to the last step, right? Now what happens when I push the stop button? See, electricity is flowing through the stop button because it is in NC position. As soon as I press the stop button, the NC has turned into FO. As soon as it turns into FO, electricity will stop going to R0. As soon as electricity stops going to R0, R0 gets deactivated. Because R0 got deactivated, see what is going to happen? This NO of R0 will get converted into this FC. The functionally closed of R0 will get converted into NO. Right? It got open, and now even if the stop button is left, even if the stop button comes back, nothing is going to happen, right? Nothing is going to happen. Nothing is happening. Okay, this is because of the initial condition, because I was in that forward motion. If I had been in the backward motion, see, I will just show you. it is in forward motion. Now it is in backward motion and I press the stop button. It will come to the back and stop. Right? So it had just gone forward and then I had pressed stop. So this is how the latching circuit occurs. This is how the latching circuit is created. See, again I will tell you the latching circuit is by far the most important circuit in your exam right now. It is necessary for your electropneumatics and it is also necessary for your PLC programming and electrohydraulics. Right? So hopefully you have understood the importance of latching circuit, you have understood the working of latching circuit. I'll just go through the latching circuit working once. When you press the start push button, okay, sorry, I forgot to put it on hold. When you press the start push button, electricity flows to relay 0. Because electricity flows to relay 0, the NO relay 0, which is in parallel with the start push button, also gets electricity. It gets FC, functionally closed. Then even after the start push button is left, electricity keeps reaching relay 0 through the relay 0 NO. The system will work perfectly, right? The system will work perfectly, no problem. It will continue operating continuously till I push the stop button, right? I will just pause it once again. Now what will happen? As soon as I push the stop button, NC becomes FO, functionally open. Electricity will stop reaching R0. Because it stops reaching R0, the relay R0 is going to what? The NO of the relay R0 will become FC. NO. It will become NO. And the system will come back to its original position and stop. Right? So this is how the latching circuit takes place. Latching circuit is created. Okay. So with this, I will end today's lecture. And in the next lecture, I will be drawing the circuit for controlling two pistons. Okay. So thank you.